Welcome to the third part of the City-wide Inclusive Sanitation Service Planning and Assessment CWIS SAP Tool training video. In this video, we will be covering the tool outputs interpretation. In part 1, we saw how to access the CWIS SAP tool, and in part 2, we learned how to input the data. Let's go to cwisplanning.com and enter the login email ID and the password. For this demo purpose, we have already completed the data entry in the input section. Already computed results can be viewed by pressing the View Results button on the City Management page or by pressing the Edit Scenarios. Either way, we would be landing on the Systems View page. We go back to the Edit Scenarios. Any changes done to the input data would be reflected in the output charts only when the user presses Compute at the end of the Reuse section. Let's go through the baseline of the city along with the indicators. I am going to uncheck these scenarios to focus on the baseline. The year dropdown allows the user to display the values of the annual numbers such as the average household expenditure, water requirement, etc. The year is default set by the year that is set to the target year. As we see, the scenarios were arranged vertically and their indicators are arranged horizontally to either compare within the scenarios or between them. The results are presented along four major categories, namely sewer, non-conventional sewer, safe containment, and unsafe containment. Please press the question mark to get more information on the metric. All the visuals are presented both for the low-income households and the non-low-income households, with blue representing the low-income households and the red representing the non-low-income households. Let's move from left to right. In the baseline, we have a conventional sewer of 132 kilometers, contaminated sewers of 21 kilometers, 2 WWTPs, 2 FSTPs, and the tariff model is volumetric for the sewer households. The service coverage is the proportion of the low-income households and the non-low-income households that have access to a given sanitation system. We may notice in this city about 26% of the households have access to sewer, of which 24% are the non-low-income households and only about 1.4% of the households belong to the low-income households. The majority of the low-income household population of the city, that is the blue bar here, relies on the unsafe containment. This metric is used to understand the safe coverage and also who gets served by each of these hardwares. Also, the safe coverage is arrived based on the service levels of the sanitation at the containment level. Market structure represents the authorities which have the legal mandate for providing the services at each stage of the sanitation chain. The U represents the unregulated, the R represents the regulated, and if there is an U plus R, it means both the unregulated and the regulated and the utility can coexist. We may recall specifying the service models in the input section under the section Define Service Model. The public expenditure is the life cycle cost, and it includes the capital and the operating expenditure over the 10-year period for each of the sanitation hardware. The public expenditure shows the quantum of the expenditure on each of these categories and by the household type. The public expenditure in the system view is a sum of all the 11 years data, and whereas in the equity tab it is for that selected year only. Let's go back to the system view. The capex is computed by the number of additional hardware for each year and is multiplied by the capex cost per unit, inflated to appropriate indexation. This capex also includes the extraordinary repairs that are incurred in the 10-year period. It also includes the soft costs such as planning cost and cost of capital. The operating expenses over the 10-year period in current terms using the inflation rate index is included in the operating expenses. The interest charges paid over the 10-year period is also included. The conventional sewer shows the expenditure done on the sewer network and the proportionate expenditure on the wastewater treatment plant. For example, if the fecal sludge from the safe containment also gets deposited at WWTP for co-treatment, and the cost is allocated proportionate to the relative use of the WWTP between these hardware types. The relative proportion of the wastewater or the sludge deposited from each of these categories are used as the weights to allocate the capex and opex between these categories. The tool aggregates and displays the public expenditure based on the weighted share of the number of households within that category. The average annual household expenditure is the average price paid by each household or the average recurring expenditure incurred by each household type for the sanitation services received annually under the category. As the households have different containment types, the average household expenditure within the category is based on the number of households sharing each of these containment, the volume of the containment which is eventually emptied by a particular type of emptying services, and the size of the equipment such as the vacuum truck or a vacuum truck. The household expenditure is influenced by the type of service provider and the price charged by the service provider for each of these emptying service. For example, the price paid by the households within the line pit individual latrine serviced by a small vacuum truck, which are mostly served by unregulated service providers, might be higher compared to the households with the individual septic tanks that have the same volume and is being serviced by a large vacuum trucks and also provided by the regulated service provider. This indicator allows for the comparison of spending across the categories and also shows up the disparities in the price paid by the household as per their income group within the category. To elaborate, in the conventional sewer, the price paid by the household is estimated based on the total revenue from the low-income households and the non-low income household connections. The total revenue is computed as a product of the tariff per connection and the number of total connections for that type of connection. Either one of the revenue models would be applicable for a scenario. Say, volumetric tariff, the volume of the wastewater flowing from WWTP. Either one of the revenue models will be applicable for the scenario. If it's a volumetric tariff, then the volume of wastewater flowing into the WWTP from the sewer connections and the volumetric tariff rate based on the water consumption levels and the type of connections are multiplied. If it's proportion of water bill, then the volume of wastewater flowing into the WWTP from all the water connections, households, and the volumetric tariff rate based on the water connection level and the type of connection is multiplied. If it's a flat sanitation fee, then the sanitation fee per connection is the revenue model. If there are sanitation levies, it is added into the revenues. For the non-conventional sewer, if it's a condominial sewer, it's a flat fee per connection. Alternatively, if it's a simplified sewer, then the revenue is based on the volumetric fee per connection. The households also pay for fecal sludge emptying from their tanks or pits. For all emptying services, the revenue model is assumed to be a fixed fee per trip. The revenue for regulated private and unregulated private emptying and transport are calculated. The number of households served by each ENT hardware and each provider is computed. The annual household expenditure for the safe containment is computed as in the same manner as of the non-conventional sewer. Be it is a line individual pit or line shared pits, individual septic tanks and shared septic tank from the ENT revenue. The annual household expenditure for the safe containment and unsafe containment are computed from the systems arising from lined individual pits, lined shared pits, individual septic tank, shared septic tank, and unlined individual pits and unlined shared pits. Cost coverage represents the percentage of cost covered by the revenue generated from providing the sanitation services by the utility. This measure indicates how much of the direct and the indirect cost are covered by the direct or the indirect revenues. We denote this by the net profit and loss or as a ratio. The direct source of revenues from the sewer categories are the tariff paid by connection type, sanitation levies, tipping fee, etc. Other revenues include non-volumetric revenues such as fees charged. Revenue for the non-conventional category is contributed by the fees paid per connection type. The emptying and transportation charges paid by the household to the utility operated vehicles and the tipping fee to the FSTP are included in the safe containment and unsafe containment. It is important to note that the cost coverage here is represented for the public authority or the sanitation authority only. Also, while calculating the revenues, the grants and subsidies are not taken into account. However, the sewer revenues includes the collection efficiency of the direct revenues. The cost includes the operating cost of all the hardware, current and existing depreciation, existing and current interest charge. If the ratio is less than 100%, it means that the revenue does not cover the operating cost and may require additional operational support. The other measure for sustainability is the total government's cost. The total government's cost represents the cost to the public sector due to grants, loans, and transfers. This provides an estimate of the total cost incurred if a specific scenario is utilizing a loan or a grant that is chosen. This estimate goes beyond the public expenditure estimate to include key financial costs incurred by the utility such as the loan interest charges. These data are obtained from the section called the source of finance against a particular hardware, say sewer, FSTP, vacuum truck. The data that we have provided as equity, loan and grants as that are proposed to be financing the capex. The total government's cost captures the grants, loans, equity, transfers that becomes the cost to the government irrespective of the source and also includes the operational support if the net income is negative. Hence, here we can see that the total net income, if it's negative, is added to the total government's cost. The other measure of sustainability is the water requirement. The water requirement is the total amount of water required to run or use the specific superstructure and the toilet. The final value is based on the coverage and is disaggregated by LIH and NLIH. This metric allows the user to evaluate whether the city has sufficient water resources available to deliver the sanitation services planned for each of these scenarios. Under safety, the safely managed waste is defined as the percentage of waste safely managed at each level of the sanitation chain for each category. It enables the user to understand the level of safety at each stage and identify the areas of improvement. The safety levels are color coded as heat map, falling in the ranges of 0 to 29%, 30 to 69%, and 70 to 100%. These are dependent on the entries of the percentage serviced by each type of emptying and transportation method from each type of containment system and the percentage of fecal sludge or the wastewater that gets delivered to each type of the treatment facility. The drop down of the year shows the average household expenditure or water requirement during a particular year within the projected 10-year period. If we move to equity, the public expenditure is broken down into capex and opex. It may also be useful to look at the capex and opex annually and also as per the public expenditure per capita. In the sustainability view, the total government's cost, that is, the grants and the government's transfers, are captured by each category with their relevant cost coverage. The 10-year, that is, the net profit or loss for the utility and the private sector are shown here. As this includes depreciation, you may notice a fall in the year when there is a completion of investments. In the investment tab, under the available finance and required investments, this compares the sum of all the finances or the source for the scenario along with the projected capital investments from the utility. This can be compared with how much investments the households have to bring in. If there is a gap between the available investments, if there is a gap between the available finance and the required investments, either we should strengthen the source of finance or reduce the investments.